Have you ever wondered what actually happens behind the scenes in those few short seconds from the moment you click send to when your message is marked read on an office chat app? Picture this scenario. You work at a company with 500 employees. You need to check a reimbursement status with Ken from the accounting department. You open the company's instant messaging system, find Ken's avatar, type a line of text. Hey Ken, has last month's travel expense been approved yet? Hit send and wait. A few seconds later, the message status changes to delivered. A moment after, it changes to read. Then Ken replies with a sticker. It all seems very simple, right? But what if I told you that to make this simple experience seamless and fast, a massive system is running in the background? It has to handle real-time connections, organizational charts, permission control, message storage, full text search, and various integrations. You might start to wonder, how on earth was this system designed? Today we are going to talk about an enterprise instant messaging system called EnterpriseIM. But we won't just talk about what it is. We want to share with you how a system specification is analyzed and designed step by step from absolute scratch. This method actually applies not only to instant messaging systems but also to any system you build. Let us first define the scenario. EnterpriseIM is an instant messaging system built for internal corporate use. You might say, isn't it just a chat app? Why not just use Line or Slack? Indeed, there are many mature communication tools on the market, but for medium to large enterprises, there are certain requirements that external chat apps simply cannot meet. For instance, the company's organizational structure. When you open the contact list, you want to see your company's department tree rather than a cluttered list of random contacts. Another example is security. Some confidential conversations must be transmitted within the internal network and cannot pass through external servers. Furthermore, there are integration needs. You want the approval system to push notifications directly into the chat room, or even have a bot help you query order statuses. This is the exact problem that EnterpriseIM solves. It references a business-grade UI design called Dreams Chat and adopts Microsoft's SignalR as the real-time communication technology on the backend to build a full duplex data highway. What is full duplex? Simply put, it's like a phone call. While you are speaking, the other party can also speak. Both sides are communicating at the same time, unlike a walkie-talkie where one person has to finish speaking before the other can start. Now let us talk about SignalR. This is the core technology of the entire system. What is SignalR? Let us use a simple metaphor to understand it. Imagine you are on the first floor of an office building, and your colleague is on the 10th floor. If you want to say something to him, what's the fastest way? You could yell, but he won't hear you on the 10th floor, right? So you need a communication system. What SignalR does is establish an always open channel between your browser and the server. Unlike traditional web pages where you click a link, the server gives you data and then the connection is closed. A SignalR connection is persistent, like a water pipe where data can flow continuously. And it's very smart. It will prioritize using WebSocket, which is the fastest and most real-time transport protocol. But if your network environment doesn't support WebSocket, for example, if some corporate firewalls block it, it will automatically fall back to server-sent events. If that still fails, it has a final fallback called long polling, which uses polling to simulate real-time communication. This process is completely automatic. The user won't feel any difference. It's like an excellent navigation system. Prioritize the highway, but if you hit a toll station, it automatically routes you to an alternative road. You just set the destination and it handles the rest. In addition, SignalR integrates a Redis backplane, which you can think of as a central telephone exchange. When your system is deployed across multiple servers, if server A receives a message, it broadcasts it to server B and server C through Redis, ensuring that all users receive consistent messages. Finally, it has a heartbeat mechanism. Every few seconds, the client tells the server, "I'm still alive." If the server doesn't receive a heartbeat for several consecutive periods, it knows the client is disconnected and triggers exponential back-off reconnection. It waits 1 second for the first attempt, 2 seconds if it fails, then 4 seconds, 8 seconds, and so on. Gradually extending the interval avoids overloading the server with simultaneous reconnection requests. With this high-speed highway of real-time communication, let's take a quick tour of the specific functional modules included in EnterpriseIM. There are 7 in total, so let's go through them quickly. The first module, Instant Messaging Core. This is the SignalR backbone we just talked about. It manages connections, schedules transmission protocols, and handles cross-server broadcasts. It is the foundation for all features. The second module, Contacts and Organizational Structure. It integrates with the company's HR system to turn your corporate hierarchy, general manager, directors, managers, engineers, directly into a contact directory. Everyone can set their status: online, busy, do not disturb, away, in a meeting, business trip, on leave, offline. 8 statuses in total. They can even customize status messages like focusing on coding, back at 3 p.m. along with an emoji. This sounds intuitive, but in the background it relies on SignalR to sync everyone's status changes in real time. If someone comes online, goes away, or changes status to in a meeting, this information must be visible to everyone within seconds. The third module, Chat Modes. It supports one-on-one private chats, group chats, and company-wide broadcasts. In particular, groups can have administrators and join permissions. There is also the @mention feature. You can @mention a person, a group, or @all in a message. The system will force a notification to ensure that person sees it. There is also a message thread feature, expanding sub-discussions below a main conversation to keep different topics organized and clean. The fourth module, Rich Media Messages, not just text. You can send emojis, voice messages, images, videos, PDFs, and Excel files. You can see typing indicators when the other party is typing. Messages have delivered and read receipts. You can react to a message with emojis like thumbs up, checkmark, or heart without needing to reply received. You can quote and reply to specific messages or forward messages to other channels. It also supports chunked uploading for large files, slicing a file of several hundred megabytes into pieces and uploading them simultaneously. If the network drops, it resumes from where it left off instead of starting over. After uploading, files are scanned for viruses. The fifth module, Unread Status Machine. This sounds very technical, but it's actually a feature everyone uses daily. The red badge numbers next to each chat room are managed here. When you read a message, the number decreases. When a new message arrives, the number increases. You can star important messages to save them or pin announcements to the top of the chat window. If you accidentally send a wrong message, you can recall it within 2 minutes. It will show message recalled on the other end. And if you read a message on your phone, it syncs and marks it as read on your computer as well. The sixth module, Historical Messages and Full Text Search. Imagine trying to find a budget figure discussed in a group chat a month ago. If you could only scroll up manually, it would be extremely painful. This module supports keyword search and allows filtering by sender, date range, and message type. Older messages are automatically archived to cold storage to reduce the database load and can be retrieved when needed. You can even export conversations as PDF or HTML for handovers or compliance purposes. The seventh module, Integration and Extensibility. This is where it gets powerful. The system provides a bot framework so you can register approval bots, query bots, and onboarding bots. It can also integrate with AI assistants to call AI directly in chat for translation, message summarization, or drafting replies. In addition, there is a webhook interface, so external systems like CI/CD servers or monitoring alerts can push messages directly into designated channels. So up to now, we have introduced what EnterpriseIM is and what it can do. But I think if you are a developer or a product manager, you might ask a more critical question. How on earth was such a complex system analyzed and designed in the first place? If you receive a request saying we need to build an enterprise instant messaging system, you cannot just start coding right away. You will definitely be asked, where is the specification? So how do you write a specification? Many people get stuck here. There are too many requirements and they don't know where to begin. They write whatever comes to mind only to find contradictions later, or they write too loosely, leaving the development team unsure of what to prioritize. This is where we need a systematic approach. We divide this process into 3 levels, from the coarsest to the finest, peeling it layer by layer like an onion. The first level, Product Requirement Document or PRD. This level answers one question: what kind of house are we building? We are not discussing what bricks or cement model to use. We are discussing who will live in this house, how many rooms it needs, whether it should have a balcony, and how many parking spaces are required. In the EnterpriseIM example, at this level we first define the core goals and scope of the project. Why are we building this system? What problems does it solve? Then we listed all possible user roles: general employees, department heads, system administrators, and future external system integrators. Next, we expanded 45 specific functional requirements, marking the priority of each, which are core features that must be in the first release, which can be added later. Meanwhile, we also defined non-functional requirements. For instance, system response must be under 1 second, support 5,000 concurrent users, and annual downtime cannot exceed 99 minutes. These numbers, which seem unrelated to features, actually determine the subsequent architectural design. The core spirit of this level is figure out what to do first, then think about how to do it. Many projects get stuck halfway because there is no consensus on what kind of house to build before starting construction. The second level, System Analysis or SA. Once we have the requirements, the next question is, how should this house be structured? You need architectural blueprints, how the plumbing runs, how the columns are positioned, and how deep the foundation should be. In EnterpriseIM, at this level, we designed the overall system architecture, how to layer the SignalR hubs. When users are scattered across different floors or offices, how are messages routed? How should the Redis backplane be deployed to ensure message consistency across multiple servers? Next, we designed a database, 19 tables in total, covering employee profiles, chat histories, message content, file attachments, and notification records. Foreign key relations between tables and which columns to index for faster queries are all decided at this stage. Then comes security design. What authentication method does the system use? How are general, employee, and admin permissions distinguished? How is data isolated between different tenants? These are all questions to answer during system analysis. We also drew many sequence diagrams, from clicking send to the other party seeing the message. What components does it pass through? How do they communicate? If a file is large, what is the chunked upload flow? Finally, UI and UX design. We referenced the layout style of Dreams Chat and defined specifications for 31 UI components, from sidebar navigation, avatars, chat bubbles, to input boxes, colors, fonts, spacing, and responsive breakpoints are all clearly specified. The third level, technical specification, or specs. Finally, we need to answer a more detailed question. During construction, how should each wall be built and each pipe connected? This level is the most specific. We define every single column in the 19 database tables: name, type, length, nullability, default value, and its corresponding type in code. 12 state enums, such as the 8 user status and 6 message status nodes, are all clearly defined with their values and contexts. API specifications are also completed in this step. 37 API and 10 SignalR methods, each with complete request parameters and response examples. The dev team can write code directly from this spec without guessing, does this field return a value or not? Error codes are also fully defined, over 100 in total, split into a dozen levels. Each error has a code, description, and corresponding HTTP status code. Front-end engineers can display the correct message to users based on these codes. You might ask, Isn't writing so many layers a waste of time? The answer is time spent writing documents is time saved debugging code. Let's do a simple thought experiment. Suppose you skip the first two levels and start coding right away. Halfway through, you suddenly realize, wait, the contact list the general manager wants to see is different from what general employees see. The general manager should see the entire company hierarchy, but general employees should only see people in their own department. If you discover this requirement halfway through coding, you have to go back and modify the database structure, API logic, and front-end display, and these changes might break other features already written. The cost of this modification is often more than 10 times higher than if you had thought it through beforehand. This is why there is an ancient rule of thumb in software engineering: the cost of fixing bugs grows exponentially over time. A requirement error can be fixed in 1 minute during the design phase but might take hours during testing and days after release. This is the exact value of the three-layer analysis. The first layer, product requirements, ensures all stakeholders share an identical understanding of what to do. The second layer, system analysis, translates requirements into architectural decisions, ensuring the technical solution supports business goals. The third layer, technical specs, turns analysis into actionable blueprints, allowing the dev team to execute directly. Furthermore, these three layers are not just done from top to bottom and finished, they feed back into each other. For example, during system analysis, you might find that the implementation cost of a certain requirement is much higher than expected. Then you go back to the first layer to discuss with stakeholders. This feature will take 3 months. Is there a simpler alternative? Or during technical spec design, you might realize an API design affects database query performance, so you go back to the second layer to adjust the architecture. This back and forth process is called iterative refinement. And because every layer is documented, the scope of each change is clear, avoiding the tragedy of changing A but forgetting B. Another key point: these three documents are for different audiences. The PRD is for everyone, including non-technical bosses and users. The SA document is for the entire development team, including front-end, back-end, and DevOps. The tech spec is for the engineers writing code. It must be detailed enough for direct implementation. This perspective is highly valuable for technical teams. We often see a single document that bosses find too technical and engineers find too commercial, so in the end, no one reads it. The three-layer analysis solves this naturally because the three documents are inherently for different readers. Today we started from a simple daily conversation in an office, talked about SignalR technology, walked through the 7 core modules of EnterpriseIM, and finally went deep into the complete analysis process of a system spec from 0 to 1. I want to leave you with one thought. Many people find writing specs painful because they view specs as restrictions, but actually a good spec is not a restriction. It is a protection, protecting the dev team from changing requirements midway, protecting the product manager from missing critical features, and protecting the user from getting a half-baked product. And the three-layer analysis method we introduced, requirements, system analysis, and tech specs, provides you with a concrete, actionable path. It's not a highbrow theory, but a practical method proven by countless projects. Whether you are building an instant messaging system, an e-commerce platform, an inventory management system, or a healthcare information system, this method applies because its core spirit is just one sentence: thinking it through before doing is always faster than coding while thinking. Next time you receive a new system requirement, why not try this method? Don't rush to code. Don't rush to choose technologies. Sit down first and think the specification through. You might find that true efficiency is not about coding fast, but about not having to rewrite. Well, that's all for today. I hope this content was helpful to you. If you are interested in system design or requirement analysis, feel free to follow us. See you next time.